are still on data handling, specifically the ogive. So we have to find the ogive for intervals, and this was the intervals of diameters. It was a whole story about some manufacturer that makes some sort of a thingamajiggy for some sort of a machine, and it looked at the diameters of certain of the components. And they looked and they saw that this was in centimeters, the distances between 2,25, 2,26, 5,26, 5,27, etc. Very small differences, and they saw that, for instance, this means that there were 12 of those components that had a diameter between 5,28 and 5,29. What was the total here?
70.
All right. So that if I ask you to go draw me an ogive, the first thing that you're going to have to do is find me the cumulative frequency. Because on an ogive, that is the first thing that you will do on your left-hand side or on your y-axis. That will be the cumulative frequency axis. Then on the other axis, it will be the intervals of the diameters of whatever this component is. So this would just be, heading would be something like the ogive. If you just write ogive, it's okay. It should be actually ogive of the diameters. So now I know already when I start, this is what I should be getting, that it should be a sloppy S, all right? Which I will have to go and ground, etc., etc. But I can't do anything unless I have the cumulative frequency. And so, give me the cumulative frequency altogether. 2, 5, 10, 22, 42,
58, 67,
70.
Alright, and that's your checkpoint. Because if you add them up like this and it gets to 70, and you do the cumulative frequency like that, it has to get to 70 as well. Those two confirm each other. So when I sketch it, where's your marks? Okay, first of all, this would be worth like 2 marks in the test for completing it. I showed you that sometimes we can also do it in reverse. I can close this up and say, well, get me the frequencies, and you'll be able to do that. Because now you saw 5 was added, so this should have been 5. 12 was added, so this should have been 12. Are you with me? If you go write that down, close this off, and try and get it yourself, you should be able to do it both ways. Or I can just erase the 5 there and say, okay, tell me what was added. Are you with me? Same principle, you should be able to think about it all sorts of ways. Where do I ground this graph?
5,25.
Okay, this is what I'm always doing over here, and I'd like you to do it as well. Grounding is at 5.25, not at 0 or anywhere else other than 5.25. On your graph as well, you are going to show me all your intervals. Now it was between 2.5 and 2.6, 2.6 and 2.7. So I was able to write it like that, or you can write it in this vertical way, or you can even write 5.25 to 5.26, 5.26 to 5.27. It's up to you. So I've grounded it, and now I have to get the upper border together with the cumulative frequency. And the moment you start doing the sketch and it goes down, you know you're doing it wrong. Because if you keep adding something, it can only say half and half the same or go up. It can't go down. So where will the first dot then be? At 5.26 and 2, which is close down here. This was your own scale. In the exam or a test, normally we give you the grid on which you have to go and measure it, and then you've got to look at the blocks and see where there's actually 2, because it then gets quite accurate. So the first one was at 2, then 5.27 at 5, 5.27 at 5, a little bit more up. Then it's at 10 by 5.28.
And then 22.
Then it's at 22, which is quite a big jump, right? Look at this. The frequencies that were added were a little bit more, lot more. So this looks like a big jump. Are you with me? All right, that was at 22. Then it was at 42, even it looks like almost a bigger jump, right? Now I don't have to wonder about the jumps. I can see where was the modal class. That one there by 20, right? But that's not the modal class. The modal class is 5.29 to 5.030. That's your modal class, the one with the highest jump. So if I looked at this, that was quite a jump, but this was even more. So on the graph, you can also see where the modal class is. That's the highest jump that was made. So that was at 42, right? And then we're at 58, which is also a big jump. 58. Okay, 67 is not that much again. And then 70 for the next one. Right, so this doesn't want to make my S nice and smooth, but I'll try my best. Okay, as smooth as I possibly can. Going through all the points for my full marks. I don't like this to see, it looks like it's almost like a point there. Are you with me? I want it smooth. Not exact. I won't be able to make my memorandum and put it on top of yours and it'll fit exactly. There might be a little bit off here and there. And that's okay, and that's the reason why when we read off of the graph, there'll be like a little bit of a leniency. So the marks would be for grounding, for the end point, and for maybe another point, and the form, that could be 3 to 4 marks. And please remember to label your axes and to give your sketch a name as well if it hasn't been given. So what do we normally then do with this? Now what we've been searching for all the time was the quartiles, because this tells me about the spread. So if you're looking for the quartiles, how do I find quartiles of any data set? You take the amount of data. How many data was here?
70.
There were 70 data pieces here. 70 digits or parts of a component, right? There were 70 of them. Where's the middle of that? Are you with me?
Yes.
So you take your 70 and you divide it by a half to get to 35. That would be my Q2. But if you half that again, that'll be 17,5, am I right? So at 17,5 exactly, I'm going to find my
Q1.
which according to me looks like, and now this is difficult, because this is already 5,28, 5,29, so maybe that'll be 5,286 for me. Yours might look more like 7, according to what your graph says. So that'll be my Q1. My Q1, 5,287, I would think. Now it makes sense to say 287 because there's 228, 229 is going to be somewhere in the middle, but again not 2876321. Doesn't make sense that you say that, although it could be. Then for the middle of that, you have to give me the 35. What did you get? Mine looks like 5,9 maybe, or 9.8, I'm not sure. And then the same here. Do you see that these measurements for Q1, Q2, and then I'm adding 17.5 here again, right? It's 42, comma, no, 52. Am I right?
Yes.
52,5 should be my Q3. And then from there to 70 should be exactly the same again. What am I trying to show you? That this distance is exactly the same. Because it's quarter, quarter, quarter. Is these going to be the same? Because it's all about the spread. How has this thing been spread? The dispersion, with the measures of dispersion are Q1, Q2, and Q3 for me would have been, I would say 533. Okay, because it was 5,30, it's 530, I don't know. But not 1, right, because that's the next one. So all that matters is that it's in between those 2 points. And in between those 2 points. It can't be outside of them. Because then I'm going to say it can't be. It's impossible if you did your sum right. It couldn't have been. So for the quartiles. Now what does that mean again? Now I can come to questions like, which wasn't a question that you were asked. How many, let's write it down. How many of the components had a diameter of more than, let's say 5,315. Okay, it makes it difficult in this particular question because it was so small. Because I've got to go according to what's there. So I'm asking, how many of the components had a diameter of more than 3.315? Can I not see it here? No, because it's somewhere in between there. Do you agree? So, I don't know how many of them there were. You use your graph, and the question normally says, use your graph to find out how many of the components had a diameter of more than 3.315. Now, where's 3.1315? Agree? 3.31, 3.32, so that should be 3.315. Do you agree? So what am I going to do with it? Measure off your graph. Measurement from the x-axis up to the top. So that should be round about, please use a ruler, not like me. Okay, let me say that this is my answer here by A, because I'm not going to tell them I read it off there at A. According to my A, it looks like 64. Do you agree with me? Don't go silly. And also now these are components. So 64,2 components makes no sense. It was either 64 or 65. You with me? So I'm measuring off 64. So my answer here is 64. No, you got 1 out of 3 maybe. What was the question? Yes, you had to go read off there by A. But the question was, how many of the components had a diameter of more than that? So 64 up to 70, which was the total. And sometimes the marker also adds the 80, then you subtract it from 80. No, your highest mark was at 70. So from 64 up to 70 was 6. So I needed to see to get your full marks. Alright, so most kids get that mark, but they forget what actually the question was. How many of them had a diameter of that much and less? 64. Are you with me? But more than, that's the one that they popularly ask, would then be the total amount. Take away the 64, that gives you 6. Does it make sense? Are you with me, guys? Or how many... what is the top 10%? In which diameter does the top 10% lie? Top 10% of what? The total of 70. So where's the top 10%? You'll actually have to go to 70, take away 7, because that's 10%. So that's why I chose 10%. Could I have asked 11%? So you'll have to work out how much is 11% of 70, find out that number, which you subtract, and then you read it off here to see what the diameter then must be. Because now normally we ask quartiles, but what I've just shown you is percentiles. Percentiles can be like the top 10%, which is a normal question for lots of people. Who lies in the top 10% of our results, etc. Not normally 9.9% or 7.8%. Top 10%, top 20%. You with me? So then we're talking about percentiles. These were quartiles, but quartiles are also percentiles. Quartile 1 is the 25th percentile, because it's 25%. And quartile 2 is also called your median, is also called your 50th percentile. And your quartile 3, your upper quartile, is also called your 75th percentile. So if I'm talking about 10%, it's actually percentiles. That's a little bit above and beyond, but just so that you know, if we're looking at other percentages, we can be talking about percentiles, which normally don't get asked, but then you've got it. So would you be able to read off of your graph? All right. sum correctly, but this had to have been 5.3. 5.3, I wrote here 3 as well. 5.315, otherwise it doesn't make any sense. How would you read off 3 points? There's nothing to read off here. There were no such things. Okay. The last bit that we could have already done when we were starting off with those data sets, because this will like be very, very small now. There's a data set of only 5 numbers. And I still want you to go and find for me the average, which is the mean. Don't forget that mean is the average, okay? The mean. And then I want you to do something different. What we're doing here is the which we're not going to talk about a lot now what it is, but we'll just work it out for now, because we've got like 5 minutes left. So you punch everything into your calculator, still under data handling, data, you punch in your data and you go to stats and you find other variables, your mean. And what is your mean? 20. Does it look like it could actually be the mean? Look at those numbers, you see it? Okay. Now the standard deviation is also there, but it's not, I think it's X stripe, and then you've got the standard deviation, not S, but standard deviation. I think it's number 3 on your calculator. Yes. Under data, under variables, what is the standard deviation, please? 2? 2 decimals, please? 82. What it means is, because if I ask you for this question in an exam, you had 4 out of 4. 2 for the standard, for the mean, and 2 for the standard deviation. What it now means is that within one standard deviation, normally 2/3 of your data will lie within one standard deviation. I'll show you a sketch just now. So within one standard deviation should be, in general with a normal spread, should be 2/3 of your data. For today, if you just punch the calculator and you got to those answers, I'm happy with you. So if I ask you then, how many data pieces lie within, how many data items lie between, or within is a better word, within one standard deviation. Then you do the following. You're looking at an interval. And the interval is the mean minus the standard deviation, and then the mean plus the standard deviation. Now tell me what that is here. It was 25 minus 2,82. Give me an answer, please. Okay. 22,18, right? So what does that mean? I've got an interval. How many of the data pieces lie within there? The data pieces. Between 22 is over here somewhere, right? And 27,82 is somewhere there. So 1, 2, 3 of the 5. 3 data pieces. Items. I just want to know 3. And that's normally what's going to happen, because 3 out of 5 is 60%. Are you with me? Now, in general, 2/3, approximately 2/3 of the data should lie within. So we'll talk about it again tomorrow. But the larger your standard deviation is, the larger this interval will be. The more, the wider spread it will be. And questions like that will be asked. If the standard deviation was 10, this data would have been much wider spread. So standard deviation is also a measure of dispersion, of how wide and spread something is. So go find for me number 9.111. There's point 2 and point 3 that you also have to go and do for me for homework, please. Point 2 and point 3. And on the other side, point 4. Yes, point 4. Right. So you've got 2, 3, and 4 to do for homework. All you have to do is punch in the data, get those 2 values. Then we will do some things like this in the class. So please leave a little bit of space open because every time I'm going to ask a different question here. Just for all of them, find me the mean and the standard deviation.